So today we shall talk about subtraction of vectors, and we will try to understand subtraction in terms of what we have already learnt, that is addition. So subtraction will follow from addition, and we will see how by understanding the addition of vectors well, we can very easily follow how we subtract vectors. Okay, we don't have to learn anything new here, we don't have to learn any new expressions. It comes directly from addition by just making a small change. So subtraction of vectors in theory should be taking the difference of one vector from the other. So for example, if I try to write vector A minus vector B, this is when we will be subtracting vector B from vector A, isn't it? Now see that mathematically this expression can also be written as vector A plus minus vector B, isn't it? Mathematically the two expressions are the same, but physically what is the meaning of this expression? Physically this expression means that we are trying to add vector A with negative of vector B. We all know now that minus vector B is nothing but negative of vector B, which is a vector which has the same magnitude as that of vector B but just pointing in the opposite direction, right? Let's try to look at it diagrammatically. What it means diagrammatically is, if this is vector A, let's say, and this is vector B, both of them make a certain angle with each other. Let's say that angle is theta. So when we try to do vector A minus vector B, which now means we are trying to add vector A with negative of vector B, we will first require negative of vector B. How do we draw minus vector B? Minus vector B will be just a vector which is pointing opposite to the vector B and having the same magnitude as that of vector B. So this will be a vector minus B, and now we are supposed to add vector A with vector minus B, and we know how to add vectors, right? In this case we can use the triangular law easily, and just by connecting the tail of vector A with the head of vector minus B, we will get the difference of the two vectors. We can call it vector D, which is the difference vector, right? Now since we are in theory we are still adding vectors, and we already know that the magnitude of resultant of two vectors is given by square root of a squared plus b squared plus 2ab cos theta. This we know from our previous videos, where theta is the angle between the two vectors to be added, right? Here in this case, look carefully that when we try to add vector A with minus vector B, we need to get the angle between vector A and minus vector B, which from the figure will be this angle. And we can see carefully that this angle is nothing but 180 minus theta. So all we need to do in order to get the magnitude of vector D is that in the expression for resultant, magnitude of resultant, we just replace theta with 180 minus theta. Everything else will remain the same, because understand that the magnitude of vector B and magnitude of vector minus B is the same. So there will be no change in the magnitude of the second vector. So vector magnitude of vector D then you can easily write as a squared plus b squared, which will still be the same because magnitudes are same for vector B and vector minus B, plus twice of ab into cos of theta will now be replaced by 180 minus theta. And we can simplify this expression because we know that cos of 180 minus theta is minus cos theta. So this becomes a squared plus b squared minus 2ab cos theta. So this becomes our relation then for the magnitude of the difference of two vectors. Mind you, here the angle theta is still the angle between vectors A and B only, right? So you need to be careful with that. We can also find out the angle that vector D makes with vector A. In order to get the direction of vector D, the difference vector, let's try and find out this angle alpha. So if we just recall how we used to find the angle phi, which the resultant of vectors A and B used to make with vector A, the expression, if you can remember, and it is there discussed in the previous videos, it is given by b sin theta divided by a plus b cos theta, right? So on the same lines, we can just replace theta with 180 minus theta to get tan alpha from here as b sin 180 minus theta over a plus b cos theta, cos of 180 minus theta again. And what we need to do is we can simplify this, because we know that sin of 180 minus theta is sin theta itself, whereas cos of 180 minus theta is minus cos theta. So, it will be a minus b cos theta in the denominator. So, this becomes our expression for tan of the angle that the difference vector d makes with the first vector a. You see that these expressions are directly coming from the results that we have already obtained for addition of vectors, resultant of vectors, right. So, we have not done anything new mathematically here, we have just tried to understand what changes to make in order to replace addition with subtraction. So, this is how we can easily deal with a vector subtraction. Now, the next thing that we can understand about vector addition and subtraction is that vector addition is commutative. Vector addition is commutative. What does that mean? It means that if two vectors are to be added, in whatever order you write them, it does not make any difference. So, vector a plus vector b is the same as vector b plus vector a. Whereas, if we look at the subtraction of two vectors, vector a minus vector b, we all understand that this will not be the same as vector b minus vector a. In fact, vector a minus vector b can be written as negative of vector b minus vector a, isn't it? Mathematically, this is how we can write it, and this makes us understand that vector subtraction is actually anti-commutative. Vector subtraction is anti-commutative. So, these are the basics about vector addition and subtraction. We can just take up a small example to understand how we work with vector subtraction in basic cases. So, let us say we have a vector a having a magnitude of 10 meters, it is a displacement vector, and there is a vector b having a magnitude of 15 meters, and the angle, the theta that they make with each other is 45 degrees. You are supposed to find out the magnitude of the difference vector d as well as the angle alpha that the difference vector d makes with vector a. So, we can directly use the relations that we have studied. We know that vector d is given by square root of a squared, which in this case will be 10 squared, plus b squared minus 2ab cos theta, right. We can simplify this expression to get the magnitude of vector d. Similarly, we can find out tan of the angle alpha that the difference vector d makes with the first vector a, which by definition is b sin theta, which in this case is 15 sin 45 divided by a plus b cos theta, a minus b cos theta, actually 10 minus 15 cos 45. So, we can simply solve these expressions to get our answers.